So in this problem, we have a Taylor series for a function. We're not told what function it is. It's given by this particular series, and it converges to f of x for this particular interval, where r is the radius of convergence of the Taylor series. It says to find the value of r. So we're looking for the radius of convergence. And anytime you're looking for a radius of convergence, you can use the ratio test. So I'm going to use the ratio test here for absolute convergence. Do the n plus first term. Now the negative ones aren't really going to apply here, so I'm just going to ignore them because they're going to be outside the absolute values. So this is 2 to the n plus 1 over n plus 1 times x minus 1 to the n plus 1. And then I'm going to multiply by the reciprocal of the nth term, or same thing as dividing by the nth term. So that will give me 2 to the n on the bottom, x minus 1 to the n on the bottom, and then n on the top. Now when I go to simplify this, I'm going to get 2 on the top. I have an n and an n plus 1 that don't cancel, and then I end up with an x minus 1 on top as well. So I'm letting the limit as n go to infinity. So I'll look at the n stuff, and that's going to go to 1 because that acts like its highest degree term. So then this goes to the absolute value of 2 times x minus 1. Ratio test says this converges if this is less than 1. So in order for the absolute value of x minus 1 to be less than 1, x minus 1 has to be less than 1/2, the absolute value of it does. And that is what they were asking you to find. X minus 1 was less than r, radius of convergence. Value of r is 1/2. So for part B, find the first 3 non-zero terms in the general term of the Taylor series for f prime about x equals 1. So this is the f around x equals 1. We're looking for f prime. And you can either do this by generating the first 3 terms of f and then taking the derivative and then figuring out what the general term is, or figuring out the general term and then generating the 3 from that. I'm going to do the latter. So I'm going to take the derivative of this thing, and keep in mind the only thing in this that's a variable is x, so everything else is constant. This is basically going to be taking the derivative with the power rule. So f prime would be, I bring down the n, and the n cancels with this n here. So what I end up with is negative 1 to the n plus 1, 2 to the n, and then x minus 1 to the n minus 1. Because again, the n I brought down and the n that was already there canceled each other out. So now that's the general term. And I want the first 3 non-zero terms. And I believe this started at 1, so let's go ahead and put that down as well. So if I plug in 1, I believe I get negative 1 squared, which is 1, 2 to the first, and then x minus 1 to the 0, so that's a non-zero term. And then when I move that up to 2, this gives me a negative 1, so this will be a negative term. 2 squared, which is 4, x minus 1 to the first. And then I move it up to 3, so this would be negative 1 to the fourth, which is positive, 2 to the third, which is 8, and then x minus 1 squared. So those are the first 3 non-zero terms of f prime. So part C says, the Taylor series for f prime found in part B is a geometric series. Find the function f prime to which the series converges for the same interval of convergence. Now the good thing about this is whenever they ask you to find a function that represents a series, that means they're looking for what the sum actually is. And they told you that this was a geometric series, so you know how to find the sum of an infinite geometric series. So this, we have to find r, and it looks like every time we're multiplying by negative 2 times x minus 1. And if you remember, the sum of an infinite geometric series is the first term divided by 1 minus the r. And why not? I'll go ahead and simplify that. It's a super easy thing to simplify. So that gives me 2x minus 2 plus 1, so 2x minus 1. And then it says, use this function to determine f for x minus, for the absolute value, so it's interval convergence. So this is the sum for f prime. This is the function that represents f prime. We want f, so we want to take the antiderivative of this thing. Now, I can do some U-Substitution and write that out, or I can simply think in my head. This looks like natural log. the derivative of what's on the bottom is 2. It would cancel out with 2 that's on top. So the antiderivative of this thing is the natural log of 2x plus 1 at absolute values plus c.